Hello and welcome to the video. In this one, we are going to test the backend we implemented in the previous video, as no modern application is complete without testing. If the project doesn't look familiar, please check out the playlist from the beginning, as this video won't make much sense without context. I'm going to talk about 3 different approaches that can be used for testing your oats-based backend, 2 of which I'm actually going to show in this video. These approaches will not be mutually exclusive. I would recommend to use each where appropriate. For each of these approaches, I'm going to focus on testing a single handler, getBook. Before we can do any testing, we need to install a few new things. I'm starting with npm install --save dev. First thing we need is jest, as we need a test harness. ts jest is next, as we don't want to precompile our code or our tests. We need typings for jest, so I'm adding @types/jest next. And lastly, I'm adding HTTP terminator. This package helps stopping HTTP servers on demand, as Express doesn't make this easy. Next, let's run npx ts-jest config:init, which is a ts-jest command for creating a simple TypeScript-enabled jest configuration. The last thing we need to do to complete this setup is open package.json and add an entry called test under scripts to invoke jest. Let's check if this works by running npm run test. And jest seems to be working, but we obviously don't have any tests yet, so let's fix that. The first and simplest approach of testing what we created is writing unit tests for the API implementation. This approach works well for testing the logic of your handlers, but with this approach, no actual request is going through the wire, so we can only test if the handler functions return the expected data, and possibly if they perform the expected side effects. Let's start by creating a folder under src called test. Then let's create a file in this folder called getBook unittest.spec.ts. Let's open this file and create a describe block. I'm going to call it getBook unit test. Next, I'm creating a test case using the test function. Its name is going to be getBook, and its second argument is going to be an async function. In this function, I'm creating a constant called API first, and its value is going to be a new bookstore API imp instance. Our API implementation doesn't need any input, but in case of a more complex API, it probably needs a reference to your database connection or a client library for a third-party API, so it would be worth mocking those here. Then we create a constant called response, and its value is going to be an awaited API.getBook call. This call needs an object parameter with a path field. Path's value is going to be a success function call. This is coming from the try package. And what we are wrapping with this success call is an object with a single book ID field set to 1. It's our single hard-coded book's ID. Now let's make some assertions. We expect response.status code to be 200, MIME type to be application/JSON, and we expect body to be equal to our hard-coded book, which I'm just going to copy-paste from the API implementation. Let's run npm test and see how we are doing. To summarize what we achieve with this, while the test is running, it can effectively test if our business logic works well for the typed inputs we choose, but it skips everything in the HTTP layer. While we can rule out a lots of coding errors with it as is, it would be nice to test if this actually goes through an HTTP request properly. This brings us to the second solution. Here we are going to involve the client-side code generators, and we are going to talk to a real HTTP server. Let's start by modifying our generator configuration so it also generates client-side code. Let's open generate.ts, and the only thing we need to change here is instead of the server preset, we are going to switch to full stack. This will include all the necessary client-side code, the SDK that interacts with the API we implemented, and the necessary parts for the SDK. Now let's run npm run oats, which will generate with this new configuration. Since we are generating new code, it might have new runtime dependencies. Each time the generator finishes, an npm install command will be logged with all the necessary dependencies with exact versions. Since I know for a fact that we are missing a dependency, I'm going to grab this command and execute it. And before we go on with testing, let's check out what has been generated. The most important thing is the SDK folder. Here you will find an SDK type and an SDK implementation. Let's look at the type first in bookstore sdk.ts. If you have been following the series so far, this will look very similar to the API type we were using in the last episode, and that's not by accident. The only difference between the two types are the request objects. Everything else is identical. In the API type, each request field, like body, query, header, or path, are wrapped in a try, since we don't know at compile time if the client-provided parameters will be correct or not. On the SDK side, however, we are the clients of the API, and we are providing these parameters, so we have no need for the try type. We let the TypeScript compiler do the structural validation for us. Let's look at the SDK implementation next in bookstore sdk-imp.ts. This is a class implementation of the previously mentioned type that delegates to individual functions that are actually executing the requests. You can see here that similarly to the server side, we are taking another type of adapter, a client adapter, as input, and we are passing it along to each function performing our requests. This adapter is responsible for the client-side equivalent of the server adapter's job, serializing and deserializing data using the generated serializers, and sending the actual requests. Now let's check out these individual functions that perform the requests. They can be found under the operations folder. Let's have a look at addBook, for example. They have been designed to encapsulate performing a specific request, taking a strictly typed request as input, and producing a strictly typed response as output. They are built with a very similar philosophy in mind to the Express routers on the server side. We first produce a raw request object with the full URL and the serialized input, utilizing the adapter and the generated serializers. Then we perform this request through the adapter. Then we parse and validate the parts of the raw response the adapter returns. And finally, we construct and return a type-safe response. These were the most important parts of the generated client-side code. On top of this, the new request types that the client SDK uses are placed in the requests folder. The missing serializers for query, header, and path parameters, and the missing deserializers for response headers are now in the serializers folder. And finally, the response body validators are now in the validators folder, with which we double check that the server actually holds true to the source OpenAPI document. Okay, time to get back to testing. I'm creating a new file in the test folder called getBookSDKTest.spec.ts. I'm opening this file and I'm creating a describe block with the name getBookSDKTest. First, I'm going to define a few variables and constants. Let's start by a variable called server. Its type, server, is going to be imported from the HTTP package. This is a standard Node HTTP server that Express's listen function returns. Let's define another variable called terminator next. This is not a model T800, it's simply going to be a utility object that helps us stop the server after our tests. And its type is going to be HTTP terminator, which we can pull in from the HTTP terminator package. Finally, I'm creating a constant called SDK, which is going to be a new bookstore SDK imp. It needs an adapter parameter, for which I'm going to use a new fetch client adapter that comes from a package we freshly installed after the generator finished. And for this adapter, we can provide a configuration object. And here the only thing we want to change is the base URL, which is going to be http:// localhost 5000. We are set with the variables. Next thing we need is a way to start our server fresh before each test and stop it after each test. If you can do this efficiently, it's great to introduce this into your tests, as it's much easier to reason about test results when you don't have internal state carried over from 5 tests before. The way I'm going to do this is by using Jest's lifecycle methods. First, I'm adding a before each function call. The callback we provide to this function will be called before each test case, so it's great for setup tasks. In the callback's body, I'm going to assign server first. Its value is going to be create bookstore server.listen with port 5000. Then I'm assigning terminator, and its value is going to be a create HTTP terminator call, where we pass in our server as parameter. Let's add an after each call next. This will be called after each test case, and because of this, it's great for teardown tasks. So in the callback, I'm simply returning terminator.terminate. This function gracefully closes all open connections of our server, and since this function returns a promise, Jest will make sure to await its completion. Now that our setup is complete, let's write an actual test. I'm adding a new test case using the test function. Its name is going to be getBook, and its second parameter is going to be an async function without any parameters. In the body of this function, I'm going to create a constant called response and assign the awaited result of sdk.getBook to it. For getBook's parameter, I'm simply following the content assist. It's going to be an object literal. It needs a path field, that's also going to be an object. Then path needs a book ID field, which is going to be 1. Now we can make the same assertions as before. We expect response.status code to be 200, MIME type to be application/JSON, and we expect body to be equal to our hard-coded book, which I'm going to copy-paste from the API implementation again. Finally, let's run the test. And to summarize this approach, I think it's great to test how our API and business logic behaves with structurally valid input. If the overhead of starting and stopping the server and actually making the requests is not slowing down your tests too much, it can be beneficial to test like this over the previous approach, as here real data is moving between the client and server side, and you might catch more bugs that you otherwise wouldn't. Speaking of bugs, if you find anything that you think is an issue with an oats library or generated piece of code, please hop on the discussion page on GitHub or open an issue. All contributions are welcome. The last approach I haven't talked about yet is using a plain HTTP client library, like Fetch or its alternatives. You most likely know how to do this, so I won't waste your time showing an example. This can be very valuable to test edge cases, security, and in general how well your API responds to unexpected input. With that, we have reached the end of this video. I hope it was informative. If you have any questions, comments, feedback, or anything you'd like to share, please do so in the comments or on the discussion page on GitHub. Links as always in the description. I hope to see you in the next and final video in this series, where we are going to look at the client side in detail. We are going to cover a fairly common use case. We are creating a TypeScript SDK library for this API with the help of oats.